Hi, I'm Lynette.
And I'm Cecilia, and we're building IVF. With Pallet-Revive, developers can deploy their Solidity verifier contracts that they've generated from their Noir circuits directly on Polkadot. And this means that ZK is now possible on Polkadot. But what if we went a step further and made this ZK proofs native to Polkadot by making it possible for developers to deploy type-safe verifiers that have smaller binaries and also optimize on gas costs? Now, this is what we're doing with IVF. With IVF, we are allowing developers to automatically generate ink verifiers with just one command. And we're also allowing them to build performance optimized ZK verification on Polkadot natively.
So the general flow with IVF is that once a developer has the privacy logic in their Noir circuit, they can compile them to constraints and update the prover.toml with values that satisfy this constraint. And then from there, they can generate the verification key. Now, this verification key is very important because it is what will be passed to the IVF generator in order to create the verification contract in ink. This verification key contains polynomial commitments from the privacy logic that the developer has written. And then from there, the next step is to generate the ink verifier contract by passing the verification key to the IVF generator. And then it will pass the VK into field elements and create a new ink version 6 contract that has the necessary fields from the verification key. The next step is to, of course, compile the verifier contract using cargo contracts to RISC-V bytecode and deploying it directly onto Polkadot Packet Hub. The verify function on the contract is now callable on the main application logic, allowing for on-chain verification whereby users can submit proofs and public inputs, and then the contract will run the Sunset protocol, and it's using the BN128 precompiled that are provided by Pallet-Revive, and then it will return either a success or failure based on the validity of the proof. So the first step that developers need to do in order to use the IVF generator is to clone the IVF repository, and then once they've cloned it and written the NWAC circuit with the main privacy logic, they can compile it and obtain the verification key. So this verification key is what we're going to be passing through this command directly to our ink generator, and then the output will be in the generated verifier folder at ink version 6 smart contract. So as you can see right here, we can see the size of our verification key, and then see how it has been passed into field elements, and then the field elements are placed into the main contract, which is lib.rs. And once this logic has been updated, depending on the complexity of your circuit, you can compile it. So just cd into generated verifier, and then cargo contract build. So once you compile the generated verifier contract, you can get the PolkaVM raw binary, which is what we're going to be deploying directly onto Packet Hub. Another thing with IVF is that we have built it in a way that it can handle verification keys of different sizes. So different circuits produce different number of field elements, and so it's open to any kind of circuits that developers can write. So the main function that we need to focus on, or the developers need to focus on, is the verify function, which takes a proof and public input. So when they're writing the application logic in Ink Smart Contract, they're going to have a cross-contract call to this verifier contract directly to this verify function, and that's what is going to be handling the proofs and validation logic. And so with IVF, that means you can now build privacy preserving applications on Polkadot natively. Thank you.